Problem 410 is essentially the same problem as 4.9. The only difference is we had a force of tension pulling off to the right. Now we have a force applied at an angle of 40 degrees downward onto the mass on surface. And so this picture, since this previous picture, all the forces are there except for this force F right here. It's pushing down. Free body diagram, only difference is that the force is pulling down now in the fourth quadrant at an angle theta. Force is 75 newtons. The givens are force is 75 newtons, the angle is 40 degrees, mu is 0.2, and the mass is 12 kilograms. And we're looking for A sub x again, which will be off to the right. So we need to know how to find the force of friction. We need to sum the forces in the y to get the force of friction, and sum the forces in x and set them equal to mass times acceleration in the x. When we go through the sum in the y, you'll have a normal force up, but you'll have a negative force of gravity and a negative component to the force in the y direction. If you solve for Fn, you'll get the force of gravity plus the y component. And if you multiply mu times the normal force, then the force of friction is mu times the weight of the object plus the normal force. So if we sum the forces in the x direction, that's the positive x component of the force F minus the force of friction, and that's got to equal the mass times acceleration. If we solve for the mass times acceleration, that's going to be the x component of the force, that's F cosine theta, minus mu times the normal force, which is Fg plus F sine theta. So again, separate out of the terms so I can combine the F terms right there. F cosine theta, mu times Fg minus mu Fg. Now this is minus and that's a plus, so this is still a minus, mu times F sine theta. Factor out the F term, cosine minus mu sine theta, minus mu mg, and divide both sides by m, and the acceleration x direction is the ratio of F to m. The trig functions times mu, and then minus mu times g. Then simply plug in the numbers, and the acceleration in this case is 2.02 meters per second squared.